I'm excited about this tutorial because we are going to answer a question you all have been asking for a while, which is why in the world don't we have to use prefixes for ionic crystals, right? You all have been very frustrated on many occasions at this point at our naming rules. And the rule that has confounded us most of all is that when naming ionic crystals, crystals. It would be really nice if I could just spell today. Crystals don't use prefixes, right? And what we're going to learn today is that we don't use prefixes because we don't need them. You don't need them. And you will see why. Just by knowing the two elements that are involved, or in some cases, it's even more elements, and we'll get into that later. Just by knowing the ions involved, you can know exactly what the chemical formula is for ionic crystals. And that is something that is different from covalent compounds. Let's go ahead and begin. So in the ionic bonding tutorial we did way back then, way back at the beginning of this unit, we saw that ionic compounds are held together because of positive ions and negative ions, right? It's an electrostatic attraction. And the ionic formula just tells us the ratio between the number of positive ions and negative ions. We're going to sort of go back over that in a moment. So if this is not quite tickling a memory in your brain, it will. So here we're going to look at why atoms form ions with certain charges and how we can predict the formulas of ionic compounds. To understand why atoms either gain or lose certain number of electrons when they form ions, we have to remember that the noble gases never form ions, right? We've spoken about that before. In fact, it's rare to see the noble gases form bonds in general. They do occasionally, but they never form ions. And the reason is that their electrons are already in a very stable state. The atoms react with each other to become more stable, but since the noble gases are already stable, they don't react. Many atoms form ions that have the same number of electrons as one of the noble gases, right? We've talked about that, and we've actually talked about that more with covalent bonding in the form of the octet rule, saying that atoms, quote unquote, want to have a noble gas configuration. Well, same kind of thing happens with ionic bonding. Elements will lose or gain electrons to try to have a noble gas configuration in their valence shell. So we can use this fact to help us predict what the charge on an ion will be. In this tutorial, we're going to do it in a way that looks at the total number of electrons, which is a little bit different than we've done in the past. This is just another way to look at it, right? Both ways are accurate. Both ways describe the same thing, but it's good to see multiple ways of explaining the same thing. So in this case, let's look at a neutral sodium atom and say, well, how many electrons does it have total? So it has 11 total electrons. When it forms an ion, meaning when it gets a charge, it's going to either gain electrons or lose electrons so that it matches one of the noble gases, right? And so what we want to ask here is how many electrons will sodium's ion have? So when sodium forms an ion, how many electrons will it have? It's not going to have 11. We know it's going to either gain or lose, but how many will it have? So there are two ways that sodium can match the number of electrons of a noble gas. It can either gain 7 electrons, going from 11 electrons to 18, like argon, or it can lose an electron, 1 electron, to have 10 electrons like neon. Out of these two choices, which do you think is more likely to happen? Is it going to gain 7 electrons or is it going to lose 1? Well, for a variety of reasons. First of all, because of the simplicity. But second of all, sodium is not a very electronegative element, right? It's not spending a lot of time or energy pulling electrons toward itself. This is just not going to happen. It is not going to pull 7 electrons to itself from other atoms. That is not going to happen. So sodium always loses an electron to become a +1 ion with 10 electrons, just like neon. So it's always going to lose an electron to become like neon. Let's look at chlorine then. So looking at it here, let's see if we can do that same thought process. Chlorine can either gain an electron to have 18 like argon, or it can lose 7 electrons to have 10 like neon. What do you think is more likely to happen? Hopefully, you immediately said, oh, well, it's way easier for this electronegative atom, this very electronegative atom, to just pull an electron into itself and become like argon than it is for this very electronegative atom that wants to pull electrons toward itself to lose 7 electrons to become like neon. That's not going to happen, right? Chlorine is always going to gain an electron to form a -1 ion, so an ion with a -1 charge, with a total of 18 electrons like argon. Let's look at barium here. And at first you might think like, ooh, this is hard, but just like look at it, right? Let's actually look and see what this energy level looks like. Notice that the transition metals are blanked out. We have not discussed transition metals when it comes to creating these formulas. We haven't discussed transition metals when it comes to naming. We haven't discussed them, frankly, a lot in this course at all. So for right now, just ignore them, right? We're only going to be looking at this energy level, and in this energy level, we only care about the elements that are in the s block and the elements that are in the p block. Remember, these are our s orbitals, these are our p orbitals. So let's just worry about those. Do you think that barium is going to gain electrons, enough electrons to be like radon? Is it going to gain 30 electrons? Look, 50, it's got 56, right? Is it going to gain 30 electrons to get to 86 electrons like radon? Or is it going to lose 2 electrons to be like xenon? What do you think is more likely to happen? Hopefully, you very confidently said, okay, we are not about to gain 30 electrons here. It's just way, way easier for barium to become like xenon with 54 electrons. And so we will know and very much expect barium to lose 2 electrons when it becomes an ion to form an ion with a +2 charge. If it loses 2 negative charges to become like xenon, it will be left with an imbalance of 2 extra protons, right? Because it's lost 2 electrons. So those extra 2 protons that are not balanced out by electrons anymore are going to cause the atom, or that has now become an ion, to have a +2 charge. Let's look at one more example here. What about oxygen? So what do you think is more likely? Is oxygen going to lose 6 electrons to have 2 like helium? Or is it going to gain 2 electrons to have 10 like neon? Hopefully by now you say, oh no, it's definitely going to gain 2 electrons to have 2 like neon. And that's exactly what we see. So oxygen forms an ion with a -2 charge. That's what oxygen does. When it becomes an ion, that's what it's going to do. Many atoms form ions so that they have the same number of electrons as the nearest noble gas on the periodic table. In order to form an ionic compound, we need at least one atom that's going to lose electrons, and we need at least one atom that has gained electrons. And the reason is that's why they become attracted to each other. That is the basis of the ionic bond, that we need one atom that's overall positive charge and at least one atom that's overall negative charge so that they can have an ionic bond. From the ionic bonding tutorial, we know that positively and negatively charged ions attract and are held together. But what we're going to look at right now is that the total number of electrons lost must equal the number of electrons gained. Let me just say that again. However many electrons one of the atoms lost has got to be gained somewhere else. Those electrons are not just going to fly out into, space. The reason that it lost those electrons is because some other element gained that same number of electrons. All right, and this is how we can actually predict the formula for ionic compounds just by knowing the elements. So let's do a simple example. We've seen this example many times before. If we form an ionic compound between sodium and chlorine, we know that the sodium atom is always going to lose an electron, right? It's going to lose one of its 11 electrons to become like neon, which has 10 electrons. And so that's how it gets its +1 charge. Now what happens is the chlorine atom gains that electron to form a -1 ion. And that electrostatic attraction is what forms an ionic bond to create the ionic crystal sodium chloride. Since the electrons given and taken are already balanced, right? Sodium wants to get rid of one, chlorine wants to gain one, then the compound is going to form with a 1-to-1 ratio, because for each sodium that loses an electron, we need one chlorine to gain that one electron. So we write the formula as just the very simple NaCl, sodium chloride, because we need 1 and 1. The sodium atom, as we already said, is able to give one electron when it forms a positive 1 ion. But look at what's going to happen here. The oxygen, as we already said, needs 2 electrons to get to its noble gas configuration, right? So where is it going to get its second electron from? Another sodium atom, right? So this sodium atom is going to become an ion when it gives up an electron as well, right? Each of these sodium atoms gave 1 electron. That's what sodium always does. And so we need 2 sodium ions for each 1 oxygen ion in order for this to work out, right? This relationship has to work out. Sodium wants to give 1, oxygen wants to take 2. So oxygen needs 2 sodium atoms in order for this ionic bond to work. So since the ratio of sodium atoms to oxygen atoms in the compound is 2-to-1, this formula is going to be Na2O. So this little 2 here, right, the little tiny 2 right in front of the sodium, tells us that there are 2 sodium atoms to 1 oxygen atom, right? Or in this case, 2 sodium ions to 1 oxygen ion. Let's see if we can actually do this by ourselves, right? So let's analyze the situation here. What is going to happen to this calcium atom? If it wants to form an ionic bond with fluorine, it's going to have to reach one of the noble gas configurations. Is it more likely that it's going to gain 16 electrons to become like krypton, right? Go from 20 electrons to 36? Or is it more likely that it's going to lose 2 electrons to have 18 like argon? Hopefully you can very confidently say, oh, well, it's way easier to lose 2 electrons. And so calcium here, let's just sort of make a picture of that. So it's going to lose 1 here, and then it'll lose 1 to get to this configuration, right? And this is going to form a calcium ion with a +2 charge because it's lost 2 electrons. So those extra 2 protons now that don't have electrons to balance out will have a charge of +2. Fluorine, on the other hand, only wants to gain 1 electron to have 10 like neon, right? Look, it just wants to go 1 step over here to have 10 like neon. Well, that's going to cause fluorine to become the fluoride ion with a -1 charge. So let's put that in here and see if we're right. So we want to say that calcium is going to form a +2 ion and fluorine is going to form a -1 ion. And it says, you got it. Calcium forms +2 ions and fluorine forms -1 ions. So let's see what kind of ionic formula we need to make here in order for these charges to balance out, in order for this ionic bond to work out, this relationship between the atoms to work out. So let's take our calcium ion. We already said the calcium ion is going to have a +2 charge. And we need to, where did those electrons go? They have to have gone somewhere where we can say one of them went to this fluoride ion, but we still have another electron unaccounted for, right? Calcium got rid of 2 electrons. So we actually need another fluoride ion to account for the 2 electrons that were removed from calcium, right? Because each fluoride ion only took 1. So we need 2 of these to pair up with 1 of these. And that forms this ionic formula of calcium fluoride, where we have a little 2, right? We have a subscript of 2 in front of the fluoride element symbol, the fluorine element symbol, to indicate that we needed 2 fluorine atoms. We needed 2 fluoride ions to match up with 1 calcium ion. What about lithium and nitrogen? And don't get scared, right? When we see, oh, we haven't done nitrogen before, don't worry about it. Let's just see what it actually looks like. Let's start with lithium. So is lithium going to gain 7 electrons to become like neon, going from 3 to 10? Or is it going to lose 1 electron to become like helium? Lithium is always going to lose 1 electron to become like helium. And that's going to cause it to form a +1 ion. Now let's look at nitrogen. Is nitrogen going to lose 5 electrons to become like helium, or is it going to gain 3? Nitrogen is going to gain 3, so it's going to have a -3 ion. And that says that we're correct. So let's make this crystal then. So this time we have our lithium ion that gave up an electron, right? So let's put in our nitrogen. Well, we're not done here because nitrogen needed 3 electrons to form this ion, and we only got 1 from this lithium. So let's add another lithium. That was a second electron. We still need to add another lithium. Now the charges are balanced. So look at this. When we look at our positive side, our positive ions, we have 3 positive ions with a charge of +1, and that gives us a total charge of +3. Meanwhile, our anion had a charge of -3, and so we just need 1 of those anions to match up with 3 of the cations. This gives us a formula of Li with a subscript of 3 to indicate that we have 3 lithium atoms, or 3 lithium ions, and the element symbol for just 1 nitrogen. Remember that when we just have 1, we don't include the little subscript 1 for the chemical formula. Let's do another example. So here, aluminum, is it going to lose 3 electrons, 1, 2, 3, to become like neon? Or is it going to gain 5 electrons to become like argon? It's easier for aluminum to lose 3 electrons to become like neon. So we're going to say that aluminum is going to end up with a +3, a +3 charge on its ion. Meanwhile, sulfur is going to gain 2 electrons, right? It's way easier to get from 16 to 18 than it is to go from 16 to 10. So sulfur is going to gain 2 electrons to form a -2 ion. Let's make this ionic crystal. So let's add in our cation with a +3 charge, and let's try to balance that out with our anion. Now this does not quite balance out. Look at our total charges here. So far we have a total charge of +3 and only -2. So let's add in another anion. Well, now we've gone the other way, right? Now we have a total anion charge of -4 and a total charge of +3 on the cation side. So let's try to balance it in the other direction now. Let's add some more positive charge to this. Well, we're not there yet. Now we have a positive charge of +6 and a negative charge of -4. So let's add in another sulfide ion. And voila, we did it. We balanced them. Right now we have a total charge balance of +6 on this side and -6 on this side. Here's a quick trick. When you're balancing ions, you can take the charge of the opposite ion. So let's say I want to know, hey, how many sulfide ions do I need when I'm bonding it, when I'm forming an ionic crystal with aluminum? Take the charge on the aluminum and say we're going to need 3 of these. So look, I take this number and I just say I'm going to need 3 of, it doesn't let me drag it. Sorry, it doesn't let me draw there because it wants to drag the ion. So I'm going to just put a number 3 here. I need 3 of these, right? Or maybe it would be clearer if I draw it already in the format of the formula, right? So I take this number and I make it a subscript for my sulfide ion. And then I take the number on the sulfide ion, this 2, and make it a subscript for my aluminum ion. That is a very ugly 2. Let me try that again. So what it's saying is we will need 2 aluminum ions and 3 sulfide ions. And that's exactly what we get for this formula. So that's just an easy trick to know how to do that. In this tutorial, you saw that in order for an ionic compound to form, we need to have an atom that can lose electrons and another atom that can gain electrons. Remember that it's always the metal that is going to lose electrons. The metals generally have very loosely held valence electrons, and it's the nonmetals that are going to gain electrons. The number of each atom needed to form the compound is determined by the electrons. So the total number of electrons lost has to equal the total number of electrons gained. So to make sure the compound balances, we have to make sure that the total positive charge equals the total negative charge. That's it for now.